For this problem, we need to rank the compounds from most acidic to least acidic. In this case, we're only concerned with substituent effects, as the most acidic proton in each molecule is an OH proton. Therefore, we need to look at the effects of substituents in order to determine acidity. So as we rank these, we're going to call the least acidic compound, we'll label that as 1. And our most acidic we'll label as compound 5. So overall here we have 2 substituents that have been added. We've added a boron to 2 of the compounds, and we've added a fluorine to 2 of the compounds. So given that the group that's changing is not directly attached to the acidic hydrogen, we know this is going to be an inductive effect. Boron, we find on the periodic table to the left of carbon, is less electronegative. And because it's less electronegative, it's an electron donating group. Fluorine, on the other hand, is the most electronegative element and is therefore electron withdrawing. What we should remember at this point is that electron withdrawing groups can help to stabilize conjugate bases. Electron donating groups destabilize conjugate bases. Because of that, electron withdrawing groups make stronger acids, electron donating groups make for weaker acids. So we can start by labeling the compound that has no other substituents, just the alcohol itself. And because that one has neither electron withdrawing or electron donating groups, it's going to fall in the middle of acidity. It's going to be more acidic than the ones with the donating groups, but it's going to be less acidic than the ones with the withdrawing groups. Along those same lines, the 2 that have the withdrawing groups, the fluorines, are going to be the most acidic. The effect that we find is that the closer the withdrawing group is, the bigger of an effect it has. So having the electron withdrawing group closer to the acidic hydrogen will be a more significant effect, will make it a stronger acid. So the fluorine being right next to the alcohol will make it the most acidic, and having it further away will make it still more acidic than not having the fluorine at all, but less acidic than having it right next to the alcohol. The 2 compounds that contain the boron, boron is an electron donating group, so again, the closer the boron is to the alcohol, the bigger the effect. But in this case, the effect is the opposite of what we're looking for. So the closer that boron is, the more it destabilizes the conjugate base and the weaker the acid. So when it's far away from the alcohol, that will make a slightly stronger acid than when it's very close.